function, sequencing, elements, truth tables, and etc. Propositional functions has 6 elements. First is conjunction. Conjunction, it was denoted by this symbol. It represents n. For example, P and Q. First, we will make a truth table. In this set of condition, if there is only one false in the condition, it is equals to false. The only true in this condition, if the both conditions are both true. That's how you solve conjunction. Next is disjunction. It was denoted by this sign, and it represents OR. For example, P or Q. In the set of condition, if there is only one true or they are both true in the two conditions, it is equals to true. If they are both false, it is equals to false. That's how you solve disjunction. Next is negation. It was denoted by this sign and it represents not. If you see this sign in the condition, you will just alternate the condition from true to false or false to true. For example, negation P. And in the set of condition, it was true, false, true, false. If you make it a negation P, it will be false, true, false, true. That's how you get the negation in this condition. Next is implication. It was denoted by this sign. For example, P implies Q. In the set of condition, if they are both true and both false in the given, it is equals to true. If the two conditions is not the same, for example, like this example, true, false, false, true, just look at the second condition where it implies the Q. So if the Q is false, then it's false. If it is true, then it's true. Next is biconditional. It was denoted by this sign. For example, P biconditional Q. In the set of condition, if it is the same condition, it was true. If it was not the same condition, it's considered as false. Next is exclusive OR. It was denoted by this sign. For example, P exclusive OR Q. In a set of condition, if it was the same condition, it is considered as false. If it is different from each other, it is true. That's how you solve it. I will now discuss to you finding the n term in the sequence. In this example, what is the 18th term for the sequence 2, 4, 6, 8, 10? First, get the difference. And their difference from each other is 2. After you get the difference, we will now solve the problem. First, we need to know the formula. The formula is a sub n equals a sub 1 times n means the n term minus 1 times the difference of the sequence. First, you will find a in the first number of the sequence, which is 2. Next is n. You will find n in the n term that was given to you in the problem, which is 18. So we will put 18 here, minus 1, and times d, which is the difference of the sequence. The difference is 2. Next is, we will follow the PEMDAS rule. First, we solve the one inside the open and close parentheses. 18 minus 1 equals to 17. So now, we have 2 plus 17 times 2. Next, we will multiply 17 times 2. It is equals to 34. Now, we have 2 plus 34. Then next, we add them. And it is equals to 36. 36 is the end term of the sequence.
Hello, I'm Steven Almirol. In this video, I'm gonna show you the kinds of compound propositions and how to prove it. We all know that a proposition is a declarative sentence that is answerable by true or false. There are some kinds of compound propositions. These are tautology, contradiction, and contingency. And in this video, I'll be showing some examples for this kind of statements. This example is a tautology, a compound proposition that is always true for every case. We're gonna answer the proposition first inside the parentheses, and we're applying the PEMDAS rule here. As you can see, there is an implication symbol. That means it will be only a false if the first statement is true and the second one is false, thus making the statements true, false, true, and true. Next one is, we know including the conjunction P to the P implies Q. You can see that there is a conjunction sign. That means if both statements are true, then it's true, otherwise false, making the statements true, false, false, and false. And lastly, we include the implication Q to the earlier proposition. We now comparing the whole given problem, which is P implies Q and P then implies Q. So the symbol here is the implication. Again, it will be only a false if the first statement is true and the second one is false. So the statements are true, 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 and true. So that makes a tautology statement right there. The next one that I'm gonna show you is the contradiction, a compound proposition that is always false and the opposite of tautology. In this given example, we negate first the Q, so you're gonna put the opposite value of Q, which is false, true, false, true. Then we proceed to the first parenthesis, the P and not Q. We see that there is the conjunction sign with negation. It means that if both statements are true, then it is true, otherwise false. Since there is the negation sign, we conclude that this statement is false, true, false, and false. Next is the P implies Q, which has the statement of true, false, true, and true, and the whole given problem. P and not Q biconditional with P implies Q. We can see a biconditional statement, which is if the both statements are the same, then it is true, otherwise false. So here, there is no same statements, therefore the statements are false, 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 and false, thus making a contradiction statement. Last is the contingency, a compound proposition that is neither true or false. First, we get the propositions inside the parentheses, which is P implies Q, and makes the statement true, false, true, and true. Next one is the P and then P implies Q. Using the conjunction sign, makes the statement true, false, false, and false. After that, we negate the Q, and we're now reversing the sign of Q, which is false, true, false, and true. And now the whole problem. P and P implies Q, then implies not Q. We see that there is the implication with negation sign. As we compare the earlier propositions, the results of the statements are false, true, true, and true, thus a contingency statement.
Hello, I'm John Angeles and this is set operators. Union, intersection, complement, set difference, and symmetric difference are called set operators. Operators can either append the sets, disregard one set from another, combine two sets, or point out the member from which two sets intersects. Set operators can be explained with the help of Venn diagram. Union is a set operator denoted by letter U. With this operator, members from sets A and B are combined in one set. The numbers 2, 3, 8, 9 are members of set A. The numbers 1, 4, 5, 8 are members of set B. The union of set A and B has the members 1, 2, 3, 4, 5, 9. The member or members of the set is said to intersect when it's present in both sets. If we use the same sample from the previous part, the intersection of A and B is 8. Complement is said to work with only one set. It states that the members of the set being complemented are removed. If we have the numbers 1, 2, and 3 for set A, and if we look for the complement of set A, the answer will be null set. Set difference. If you're looking for the set difference A minus B, you need to disregard the members of set A and collect the members of set B. If we have the numbers 1, 2, and 3 for set A, and the numbers 4, 5, and 6 for set B, the answer should be 4, 5, and 6. Symmetric difference is an operation that is denoted by an encircled plus sign. If you were asked to find the symmetric difference of A and B, you may list down all of the members, excluding the ones that are present in both sets. Cardinality is the number of members present in a set. If you are asked to solve the cardinality of set A, you just need to count how many members are present in the set. In this case, the cardinality of set A is 2.
Hi, I'm Brian. The topic that I will discuss is all about function. Function is a set of members that have connection to the other set of members. The properties of the functions are the following. Surjective. X is greater than the function of x. If set A have a member greater than the set B, then two members of set A make a connection in only one member of set B. We consider this surjective. For example, let A have a member of 3 members and B have a member of only 2 members. The next is injective. X is less than function of x. Once a member of set A have a connection to set B, even if set B have a greater member than set A, we consider this injective. The next properties of functions is bijective. Bijective is a functions have both one-to-one members, or set A have an equal member to set B. The next topic is arithmetic sequence. Arithmetic sequence is a sequence of number which increases or decreases by a constant amount of each term. Another example is, for instance, find the first 3 elements of the given example. A with the subset of n is equal to 5 times the subset n plus 3. N is equivalent to 1 if there's no or not have a number declared at the right side of the A. So A is equal to 5 times subset n, which is 1 plus 3. So 5 times 1 equals 5 plus 3 equals 8. Since 8 is the first element, also we considered 8 is the different, so that the next number in 8 was 16 and 24. So the first three elements of this sequence are 8, 16, and 24. Another example is, for instance, find the first three elements of the given example. A with the subset of n is equal to 5 times the subset n plus 3. N is equivalent to 1 if there's no or not have a number declared at the right side of the A. So A is equal to 5 times subset n, which is 1 plus 3. So 5 times 1 equals 5 plus 3 equals 8. Since 8 is the first element, also we considered 8 is the different, so that the next number in 8 was 16 and 24. So the first three elements of this sequence are 8, 16, and 24.